All right, let's go to the next four questions. Problem number 5 of practice test number 1. A function can be both odd and even, can it? That sounds weird, right? Because if you are talking about an integer, certainly an integer is either odd or even, and it can't be both, right? Well, when you have a question like this, it's very important to figure out what the definition is for each of these terms, right? So f of x is what you're looking for, right? To be even, f of negative x has to be f of x. For this to be odd, f of negative x has to be negative f of x. Okay, now these are the same. So that means if a function is to be both odd and even, f of x must be equal to negative f of x. What does that mean? Well, you can add f of x to both sides if you want. Okay, basically f of x has to be equal to 0. Okay, so what does it say? Well, it just says f of x has to be 0. For a number to be equal to its opposite, which is that, of course, that number has to be 0. And this has to be true for all x. Okay, is that a function? And the answer is, yeah, it is a function, right? So fx is equal to 0 for all x. That's a constant function, not a very interesting one, but it's a constant function whose graph, is just the x value, the x-axis. This function is the only function that's both even and odd. Why? Because if the function has to be even and odd, this has to be true, this has to be true, therefore this has to be true, therefore this has to be true. Okay, so there exists one, and in fact, there's only one function in the whole world that's defined on all reals where it's even and odd. So that's a sort of an odd fact, and it's even true. So that is a fun question. Okay, number 6, you have two functions defined, f and g. F is the square root of x minus 2, g is e to the 3x. F of g of x is what? Well, this is f of g of x. Okay, so g of x is down first, e to the 3x. And now f takes over. What f does is to subtract 2 from the entered value and then take the square root. All right, so we will do exactly that. This is the input, which used to be called x. Now it's e to the x, e to the 3x. Subtract 2 from it, and then put the square root on it. Okay, that's it. It's quite simple. G of f of x is, of course, f of x is down first. So square root of x minus 2 is plugged into g. Now what g does is you take the input, g takes the input, and then find out e to the 3 times that input value, which now is the square root of x minus 2. Okay, so that is the composition g of f. Now notice here, f of g is clearly different from g of f, and that is sort of understood to be a normal thing. When you switch the order of operations, when you do two things in different sequence, the result will be quite different. Okay, all right, let's go to number 7. Okay, so number 7 is a huge and just a big summary of sine, cosine, and tangent. It's trigonometry, right? And I do want you to know these values for the standard functions, standard angles, right? Without using the calculator, right? How do you remember these things? This is so complicated, right? Well, it's really not. You have this unit circle, and you think of all these angles as rays coming from the origin, and the x, so they all cross the unit circle, and where it crosses the unit, where the ray crosses the unit circle, the x coordinate is the cosine, and the y coordinate is the sine of the function. That's pretty much it. Okay, and that is the best way to define the sine and cosine. And the tangent is simply sine over cosine, which is not always defined because cosine can be 0. Right, so when the angle is 0, we use the positive x-axis And so you will look for the this point, which is of course 1, 0. That will give you cosine is 1, sine is 0. Okay, tangent is 0 divided by 1, that's 0. All right, so that's no problem. Now let's go to pi over 6. And the thing about you need to know about the this pi over 6, that's 30-degree angle. If you imagine this, this number is much bigger than 0.5, right? But you should know from your trigonometry that the y value is 0.5, 1/2, right? So that's a sine function. The cosine is the other one. And what do I mean by the other one? Well, most of these numbers are going to be either 1/2 or square root of 3 over 2. And then when pi over 4 is included, then you have square root of 2 over 2. Okay, so that's really what you need to know. Now, if you ever are confused which is cosine and which is sine, remember when the angle is really small, like 30 degrees, it's the y value that goes halfway already up like this. The x value slowly decreases from 1. And this point, by the way, this number is like 0.866. And so that you can just remember, it's the one that is much bigger than 0.5 or 1/2. Okay. All right. Now the tangent is, of course, this divided by that. You can do 1 over square root of 3. If you don't like the irrational number in the denominator, you can also call this square root of 3 over 3. It's the same thing, of course, right? You just multiply the top and the bottom by the square root of 3 to get that number. But you don't need to rationalize the denominator anymore. Okay. If you go to the opposite, negative pi over 6, the sine value changes, of course, clearly because you go to the negative territory, like here, but the cosine doesn't change, right? And so cosine is still square root of 3 over 2. And so the tangent just becomes the negative of what we had before. Pi over 4. Okay, so this is where, because pi over 4 is 45 degrees, the x and y values are the same. Okay, and so that's an easy one to remember. Both of these are the same. And that's going to be square root of 2 over 2. And that comes from that, 45, 45, 90-degree triangle where this is 1, 1, square root of 2. This pretty much gives you, if this is supposed to be 1, then this has to be divided by the square root of 2. And of course, that is the same as square root of 2 over 2, which is both the sine and the cosine value at pi over 4. And because these numbers are the same, the tangent is going to be 1. That would be this divided by this, and of course that's 1. If you go to the negative side, of course this changes, but the cosine does not, and the tangent becomes -1. All right, pi over 3, that's a 60-degree angle. This time, what you have to remember is we have gone way up here, okay? Now the x value is exactly 1/2. That's cosine, but the sine is almost 1, not quite. Okay, it's 0.866, or the other value, which is square root of 3 over 2. Okay, these appear together, right? So you should remember, if one is 1/2, then the other one has to be square root of 3 over 2 in quadrant 1. All right, so if you divide this by that, you get the square root of 3, and that's your tangent value. Okay, if you go to the opposite again, the sine changes, the cosine does not, and the tangent changes its sign. Pi over 2, that's 90 degrees. At this point, now this point is 0, 1, right? And so the y coordinate is 1, the x coordinate is 0, and 1 divided by 0 is undefined. So the tangent is not defined at pi over 2. Now the same thing happens. The tangent is still not defined at negative pi over 2, but the sine is -1 and the cosine is 0. Now just to remember, sine of negative x, I should say theta. Sine of negative theta is negative sine of theta. But cosine does not get affected by the negative. And that's because cosine is an even function, whereas sine is an odd function. Finally, pi. Pi is this point here, or pi is represented by that point here, which is -1, 0. That gives you the cosine of -1, sine is 0, and the tangent is 0 divided by -1, which is 0. Negative pi actually is exactly the same point, right? Now, I'm not saying pi is equal to negative pi, because one is a positive number, 3.14 something, the other is a negative number. They are not equal to each other. However, as the angles, those represent the same point on this point on the unit circle. So the sine, cosine, and tangent, they all are going to be exactly the same. All right, so then you have this. Now, this may look like a long chart. If you have to sit down and memorize this, that may be terrible, right? It's just like, having to memorize 10 people's phone numbers or zip code or something. But the problem, it's not that, okay? Once you understand how these values are obtained from this unit circle, where cosine is the x coordinate of the point and sine is the y coordinate of the point, then we will be able to, or you will be able to figure out all of these numbers without the use of a calculator. And that's where you should be as you begin your study on calculus. Okay, let's go to number 8. Okay, number 8 is a general question. How do you convert radians to degrees and vice versa? Okay, that's again sort of a basic piece of knowledge and a basic skill that you should be able to know or figure out. Okay, now remember the definition of a radian. One radian is an angle measure, which if you start at the positive x axis and if you go counterclockwise along the arc of the unit circle, if you go 1 unit, we stop here, and that angle represented by the arc length of 1 is called 1 radian. Okay, so that's about, it's a little less than 60 degrees, but that's what it is. And then if you just keep going, of course, if the radius is 1, then the entire circle is 2 pi, right? And so if you go to the opposite side here, you have moved pi units. Okay, if this is like in inches or something, then you have, if the radius is 1 inch, then from here to here, as you go along this arc, you have traveled pi inches. If you go to the complete circle, that's 2 pi inches, right? And so pi is 100. So what you have to remember is that pi radians is equal to 180 degrees. Okay, in other words, this and this are the same. So pi over 180 is the same thing. 180 over pi is also the same thing. So that's something you can remember. Now, in radians, you basically have pi, right? So you're going to have to multiply by 180 degrees divided by pi. So if you have, for instance, pi radians, okay, that's 180 degrees. Pi radian will be pi times 180 divided by pi. That's going to give you 180 degrees. If you have 1/2 pi, if you multiply that by 180 divided by pi, you get 90 degrees. So that's the correct way. And of course, the other way around is the inverse, right? Multiplied by its reciprocal. So multiply by pi over 180. Okay, again, if you have 180 degrees, you divide it by 180, multiply by pi, you get pi radians. So that's how you can do that. Okay, we'll go into the next video as we start chapter 9.